For question 11, what is the absolute maximum of the function? And we're given this piecewise function. So we are trying to find the absolute maximum. This is actually a closed interval. If you look at this a little more closely, you'll see that the function has a hard start at -1 and a hard stop at 3. So we can kind of add to the instructions here if we like. That is the closed interval. So that means closed interval method is what we're going to use to find this answer. So I'm going to calculate the derivative of this piecewise function. So the derivative of this is going to be -1. The derivative of the second piece is going to be 1 minus. This will be 2x over 4, which simplifies into x over 2. The derivative at -1 is fine, but at 0, if we look here, well, if you plug 0 into this, you're going to get 1. Here you see it's -1. So this thing is not going to be differentiable where these pieces start and stop with each other. There's going to be a jump discontinuity, so we do not include 0. And then here, 0 to 3. So we see here that f prime does not exist at x equals 0. So that's our first critical value. Then we need to determine, does f prime equal 0 anywhere? Well, the first piece of this function, no, it's never going to happen because it's always -1. But to figure out where the second piece might be 0, we're going to set that equation equal to 0. And we're going to see that it's 0 at x equals 2. So we have two critical values for this problem, 0 and 2. So now we're going to set up our table. And remember, we're plugging everything into the original function. So the beginning of the interval is -1. Both of our critical values are inside our interval. So 0, 2, and then we'll stop at 3. So now I need to plug these values into the original function. -1 is in this first interval, so we plug it into -x and we get +1. 0 is also in the first line, so it goes plugged in there. 2 and 3 are down here. So when we plug 2 in, we get 2 minus 1, which is 1. And when we plug 3 in, we get 3 minus 9 over 4, which actually works out to be 3/4. So we're looking for absolute maximum. So this is the largest y value that appears on our chart. So there is an absolute max of 1 at x equals -1 and x equals 2. So just like the previous problem we did when we talk about absolute extrema, the y value is the answer. So when we go back up to find our answer choice, we want +1 is the answer that we're looking for.